Yeah? Okay. It's really hard to see. So, welcome everyone. Wow. I am amazed at the number of people here and humbled, honestly. Thank you for giving me some of your time. Hopefully, we will find some useful things in this talk for you. So, I have been a singer for a long time, and I've been on stage a lot. And these lights might be some of the brightest I've ever faced, to be quite frank. So this will be interesting because I can barely see any of you. So I will ask a couple of quick questions just to get a quick poll, and I can see generally who's up here. But how many of you are actually using some sort of serverless messaging or eventing or things like that at this point? Yeah. Okay. Cool. And with that, how many of you are using like a library to wrap that, like in-service bus or mass transit or RabbitMQ? Cool. Any of you that are doing that, like interested in knowing more about the guts that happens in Azure or within the code, or are you just here to learn more about how you might integrate with those services? So hopefully we can give you some information that will be really good for you. So, and now my clicker stopped. That's neat. Why did my clicker stop? There we go. All right, so this is me. So, quite frankly, I'm very intimidated by this room, and the reason is because a lot of times when I step into a room like this, I feel like the dumbest person in the room, to be honest, and I know that a lot of you out there probably have a lot more practical experience and intelligence than I do. So, a little bit of imposter syndrome, I put a bunch of stuff up there to make it look like I'm more qualified, but ultimately, the reason I want you to see this is I do a lot of Azure training, so if you're interested in any certifications in Azure at all, I would love to talk to you and help you find resources, so you can find me around the conference for the rest of the time, or after this, and we can talk about that. And I also wrote a couple of books if you're interested in that sort of thing as well. And all these slides will be available. All of the stuff that I have is going to be on a repo as well that you'll have access to. So let me just show you that real quick. And ultimately, this QR code here will take you directly to the repo. So if you're interested in getting that repo, I'll give you a second to do that. It's ultimately under github.com/blgorman, and then Azure Queuing, Messaging, and Eventing, or something similar to that. And on that repo, there's going to be a link. So that link will take you to my personal training site where I have posted for free all the slides that you'll see today, with the exception of a couple that I just added, because like any good presenter, I feel a little bit like, oh, I might not be deep enough in the material, so I want to add more cool things. So hopefully that will work out. But here we go. So first service we're going to take a look at is going to be the Event Hub. So what I want to do today, honestly, is just give you a chance to see, actually I should have probably just left that up for one more second, because I can tell you that we're going to go through the event hubs, then we're going to go to the event grid, we're going to go to Service Bus, and then we're going to look at queues and topics within Service Bus and talk about them, and ultimately Storage Queue. And we'll talk about some different things, different approaches you can do along the way with some of those. We're going to look at code on slides. I have demos ready in case we have time, but there is a lot to cover. This is about a day's worth of training, kind of condensed into an hour. So we're going to go fast. There's a lot of slides. I hate slides, but it allows me to get all the information to you as quickly as possible. So with that, we're going to start with Event Hub. So the Event Hub is the service you want to use at Azure when you're looking for big data or streaming or IoT. And so ultimately at this point, think millions and millions of records coming in, or even hundreds of thousands, whatever, per second or per minute or whatever. Lots of events coming. So you're streaming from telemetry devices or from some other eventing from your applications, and you need to get all those events and you need to process them, and you need to be able to ingest them, store them, and work with them. That's what the Event Hub's for. So within the Event Hub, you actually, to create it at Azure, you create an Azure Event Hub's namespace. The namespace is the housing for all of your Event Hubs. You can have multiple Event Hubs in there that you can use, and ultimately kind of determines the top level entry point for how you get through with your SaaS tokens and things like that if you want to go at the top level. There's a couple of really dry pieces of information I want to give you so that if you were making decisions about applications, you know what these things are for and why you would use them. So the first thing is throughput units. You can have up to 40, and a throughput unit is essentially how much you want to ingress. So one throughput unit is about 1 megabyte per second or 1,000 events per second. So if you need more throughput units. And Event Hub does charge by throughput units. So just keep that in mind. And it allows you to egress up to 2 megabytes a second. If you want to do the auto capture to cold storage, which is what the demos would do, you would end up having that cold storage. You need to have at least a standard or better tier. So when you create it, you just give it a namespace name. What you'll notice is really interesting to me is that it actually lives in Service Bus. So this is the one place in Azure where they named something funny, right? No. Okay. But ultimately, Service Bus is the namespace for both Event Hub and Service Bus, which can be confusing to people, but just know that the Event Hub just lives in the Service Bus endpoint namespace, and it is still its own thing. So you get your hub name.servicebus as you create it. So you can see some costing there, some sliders on how to create it, basic stuff there. Ultimately, I wanted to call out here, when you go to the next page, this auto local authentication. If you want to use SaaS tokens, you have to have that enabled. If you turn that off, your only option will be RBAC, or role-based access control. So if you'd rather use only role-based access control, you can, and ultimately you do that by turning on you can turn off the SaaS, and then you can select the roles for data owner, data receiver, and data sender, which are the same tokens you could create in SaaS tokens by using the RBAC to do that. And then of course you need a service principal or an authorized user to be able, or a managed identity to be able to go in and have the access to do either sending, receiving, or both. So when it comes down to the Event Hub, you typically have your producers and your consumers, and ultimately those producers can be anything that streams those events, that telemetry into your Event Hub, and the consumers are just the services that end up selecting that and processing it out. And that could be an application, it could be a stream analytics job, it could be even other event hubs or different scenarios. So you could have an event hub that's streaming and another event hub is consuming. You might not want to do that, but you can. So the most important part of this is the partitions. When you create your event hub, you have to determine how many partitions you want from the start. If you don't, you have to recreate if you get it wrong, you have to recreate your event hub. You can't change the number once it's created. So think about, you can have up to 32 partitions, and each one of those should actually be used to do about 1 megabyte of ingestion per second for your throughput. So if you want to have a lot more data coming in, you might need more partitions. Typical IoT load is recommended to be about 4 partitions. So other than that, the events come in and they are in order. If you use a partition key when you pass it in, and ultimately those go out and they get evenly distributed over the partitions. I'll show you a picture of that in a second. And the other important thing is the retention. Event Hub typically can be deleted after an hour, up to 7 days. If you go to the premium level, you can go up to 90 days. So within the Event Hub, then there's these things called consumer groups, and I'm going to show you a big picture of this again in a second, just so you can kind of see it. Consumer groups are used to have different processing on the same events. So think of this as competing consumers. If you have to replay data, there's a checkpoint, and the checkpoint needs to be correct for the application. And if one application moved the checkpoint back to a different previous spot in the feed, then the other one who's trying to consume would be basically replaying data. And so the consumer groups should say, okay, this data is going to be read by this consumer group, and the same data is going to be read by this other one. So if I want to do one path into cold storage and one path through a stream analytics job, I can create 2 consumer groups, and they won't compete for the data then. So that's what this all looks like. You got a bunch of producers, whatever it might be, sending data either through HTTPS, AMQP, Kafka, or and so when you do that, just know that you probably don't want to use HTTPS unless you have to, because there's an extreme overhead with HTTPS. You have to keep re-establishing your socket, basically, or your connection every time you send a data event. So with AMQP, you can keep that open, or Kafka. So then the weirdest, most confusing thing for me when I was learning this is, what the heck are these partitions? And so these partitions exist, again, to help you spread your data out and keep order. And the worst thing is, at one point, I think you can still do this, you can actually tell your code to write to a specific partition, which is a really bad idea. So what you're supposed to do is use a partition key. And that partition key then will keep your data ordered as you ingest it, and Microsoft's internal workings on the Event Hub will spread your data out evenly over these partitions, and the ordering will be maintained. And then again, the consumer groups are just different reader groups, and you can actually have up to 5 readers in a consumer group, but again, be careful about duplication if you do that. So you might want to go 1-to-1. It's probably the easiest. So this is capturing. When you create an Event Hub, if you do it a standard or better, you can capture your events automatically into storage. So you create a data lake storage, and you essentially then make sure that that's a hierarchical namespace. You then turn on the storage, the capture, and all that stuff, and it emits all of your events. So you can capture in intervals of either 5 minutes or 300 megabytes, whichever happens first, as the default, or you can change that around. So you see the time window you can change, the size window you can change. So if you need your data faster. The other thing that's interesting here is the check mark for do not emit empty files. So if you turn that on, like it is in this image, this means that if there's nothing in your data, you're not going to emit a file. Now that might seem great because you're not storing anything, but it also might be painful if you're looking at your event storage and nothing's being written. Do you know, is your Event Hub actually ingesting or not? If you're emitting empty files after 5 minutes, you would know at least you're still trying to stream stuff, right? You're just not getting your data. So the easiest way to write code, and if you haven't ever written code at the SDK level with the Event Hub or Service Bus, is going to be using these SaaS tokens. There's 3 different types of tokens you can create. You can create the managed token, which allows you to kind of have God mode over that piece of the hierarchy. So the root managed shared key is the absolute God mode over your entire namespace. So if you give your access to that, they can do anything against all of your hubs. So you typically don't really want to use that unless it's a specific case scenario. So what you typically do is go to the actual Event Hub in your portal and create your producer and your listener or consumer keys. And that way your app only has access to one hub and the data it needs. So then you get that, you put that into your code, typically in your user secrets or actually like a key vault, and you need to make sure you know the name of your hub and the connection string for your consumer. And for the sample apps that I have, the connection string and container name for the storage that we're capturing to. So, I think we're doing okay on time. Does anybody want to see? It's a very simple, I can just run the code quick and stream it into my Event Hub and consume it. Does anybody want to see that? Yeah? Okay, let's do it. All right, hopefully this won't screw up my clicker. All right, so again, all this code is going to be available to you on the repo. So you can take this home. There's actually IIC out there to create all the resources that you could run. It's not quite complete for some of the stream analytics stuff I was working on yesterday, but that's okay. How's that for size? Is that pretty good? Cool. All right, so again, the code is very straightforward when we're going to be working with the Event Hub. Ultimately, we're going to be looking at the code here, and we're going to get in the connection string and the configuration for the Event Hub connection string and name. We need a producer client and a consumer client on the consumer side, and then we have event data that we're encoding. Now this is a very generic, very simple binary string encoding, so it's not doing much, but that brings me to another important point. The difference between events and messages, right? So when we get to Service Bus later, we'll be doing messages. Here we're doing events. So if you want to get some clarification on which is supposed to be used when, think of, do I care what happens to this? Do I need to respond to something if it doesn't happen? And also, do I need state? Those are kind of your 2 determining factors. So if you don't necessarily need state, you just need information. And if you don't necessarily care if anybody handles it, you typically fire an event. Okay, here it's out. If there's anybody subscribing to this event, they can do stuff with it. If not, it's in the ether, or maybe in a queue, a dead letter queue or something. So that's kind of the first part of that. The events are more just for information that you can then use to continue processing or handle something that if it's broken or whatever. So when you run the event project here, so we'll just run the Event Hub project here. I've already pre-wired all my connection strings so that you didn't have to watch me do all that. I hope, I feel like most of you would have no problem figuring out where that would need to go. If so, ask me after. So I just published 25 events to the Event Hub queue. On the consumer side, then, this project needs to have the Event Hub consumer and also a storage account that we're reading from. So we get the blob for the file name and the file client, and we create that as we go. And then ultimately, when we're reading this in, we have our Event Hub consumer client, and our blob container client that we've basically connected to via the SAS token and the storage connection string. Again, RBAC's probably a better solution, a little bit more tricky to implement and make sure it's going to work. The SAS token will work. And the SAS token is probably in the scenario where you have a third party and you need to expose your endpoint to let them write their data into your Event Hub. That's probably your better option unless you have a principal for them in like a B2C client or something. So with that in mind, we process the events asynchronously, and it's just going to read them in through this asynchronous handler. And this is a very basic code again, but my hope is it will just give you enough to get started if you were trying to play around with this or know that, hey, I can use this to do some really cool things later. I'm struggling there because I'm on the wrong thing. So if I start a new instance of the consumer now, you're going to see, so what this was for, what inspired this idea was I had a client we were working with, they had a bunch of errors and logs and things, and they were logging from their events. And ultimately, they were logging it into log analytics, and they were logging megabyte after megabyte after megabyte. And typically, log analytics isn't that bad until you start streaming thousands and thousands and thousands of events into it, and it starts getting really big. And you're paying per gigabyte. So we were looking for a different option of can we stream data and make it so that the data can go somewhere else. Now, I'm not sure that Event Hub would have been cheaper. We never got farther than that. We were just exploring. But it inspired the idea. Let's just throw some events from a Windows machine log there and see what happens, and that's what those are. So is there any questions about Event Hub before we move on? Awesome. Cool. All right. And my clicker's gone again. It's going to be a struggle, I suppose. Okay. So again, this is just, again, really quick. There's the code highlighted again for you. You saw it in the code already. All these slides, again, are available after. So we're just going to move through these pretty quickly. That's the manual storage capture part. And then I wanted to call out a couple of other things. IoT Hub. So if you're using IoT devices or telemetry devices, you can stream directly into IoT Hub. IoT Hub is just a subset of Event Hub, which means you should be able to write the same code against either using the Event Hub SDK, and you should be good to go. So again, the cool thing about IoT is then you can move it out to the edge as well and do some pre-filtering with IoT Hub on the edge, which can be nice too. I also wanted to bring up Stream Analytics. So what is Stream Analytics for? Well, if we have data coming in all day long and I am processing these events and something important happens, how am I going to tell my application that there's an immediate need? That's what Stream Analytics is for. So you can also use it to do different types of ingestion, but typically a Lambda path where you're going hot and cold. So you create a Stream Analytics job with an input for your hub, a query that's basically SQL, and then an output, which is either an Azure function, another Event Hub, another Stream Analytics job. You can send it anywhere you want, another event. So you can also send it directly to dashboards. So now if that sensor in the hospital is detecting there's too many parts per million of some dust or something in an operating room, you can immediately throw an alert and say, hey, you can't operate there. It might not be safe, right? Or things like that. So this is a Lambda architecture I kind of stole off of Microsoft sites as well. Ultimately, I wanted to call that out because of the idea of the hot path and the cold path. So think of this as, I need to know something happened immediately. That's my hot path. My cold path is, this is all my data, so I can do postmortems. So I stream that into storage, and that's always going to be there. But my hot path is, hey, that hospital thing happened, or the temperature's too warm, or the humidity's too much in my wine cellar, or whatever that you're monitoring. And ultimately, then you can know you need to make an adjustment. So that brings up Event Grid. And for me, when I first started with these services, I was like, well, what the heck is Event Hub? What the heck is Event Grid? Why do I need both? Do I need both together, or can I do one by themselves? Like, is the event grid part of the event hub? No. So they're different services. And so I had to play around with it a little bit to understand that, but ultimately, the event grid, its main purpose is one-off events. So if I can do anything in Azure, you can typically monitor that. And that monitor says, hey, something happened. And the event grid just says, okay, here's my event. Here's the telemetry or the data from that event. So it might be a blob storage URL, or it might be somebody signed in, or somebody turned off your important VM. Whatever that is, all of those events are monitored in Azure, and anything that's monitored can trigger an event to the event grid. And once you have that, you can create subscribers on it. Send off a logic app that says, hey, somebody shut off the VM to your Slack or your Teams or whatever you're using, or even an email. And so ultimately, pretty much everything can connect and create an event source, and pretty much everything on the right-hand side here that you see can handle it. There's one other cool thing that's been recently added with Event Grid, and this might be interesting to some of you if you play around with MQTT. So if you're doing MQTT, typically IoT workload, you can actually stream it directly to an Event Grid now. Whereas before, you had to do that typically through IoT Hub. Now you can go straight to the Event Grid, and you can handle those events in Event Grid with the MQTT connection. So you can have all of your little smart things devices just sending directly to the Event Grid or whatever, and hey, shut off the lights, boom, done, whatever. All right, so filtering. So all of our events that come in, you can filter by subject, and ultimately you can use that to determine how do I want to handle this, what do I want to do with it, and listen to some or ignore others, right? Events are consumption-based. They're on a pub-sub basis. So if I don't subscribe to it, it goes into either a dead letter queue or it's gone away. And then you can create your own. So this is another thing. You can create your own events, but I want to challenge you in your mind to think, if I am thinking I'm going to create a custom event, should that have actually been a message? And again, go back to your discernment. Do I need to care if this thing was processed? And if I do, probably I want to look at messaging, because then we have a little bit more control over like retries and things like that. If it has to maintain state, probably a message. Now that doesn't mean you can't serialize JSON as an object and throw it through an event as the data payload. You can do that. But writing a custom event is a little bit trickier than using a message as well, so I just wanted to call that out. Event Grid does have an exponential backoff on its retry up to 30 maximum tries, and ultimately you can have messages with a time to live up to 24 hours. There's a dead letter queue, and the only things that won't be retried are things that basically say, this can never happen. Like, it's not a good endpoint, I don't have permission, things like that. So when you create an event grid, it's registered, oh, yes, story time. So the first thing you have to do to use Event Grid, if you don't have this registered on your subscription, is make sure it is. Microsoft Event Grid. It's not registered by default, neither is the hub. But if you create them in the portal, it'll typically do them for you. However, if you do what I did, and you create a logic app that triggers an event that needs to respond from a blob storage created event, and you don't have this registered, you might spend a couple hours trying to figure out why your messages aren't getting sent until you realize because it wasn't turned on. So I just call it out to make sure that happens. So what I have here is a quick demo. It's actually a GIF that allows me to stop talking for a minute and see you guys to watch a couple things while I talk about it, I guess overhead. But we're going to create a logic app that responds to a blob storage trigger. Again, all of these slides are in that whole thing, so you can watch this again later. You can see what's happening here. This is a very generic connection. I'm just going to use the storage connection string and my own personal account. There's other options we'll see in a second. Ultimately, we're going to connect. We're going to create a logic app, and that logic app will then respond whenever you drop any file into blob storage. And this is just one of millions of ways that you could use an event grid. But then once you have it, you'll be able to go in, review your subscription. This proves to me that my logic app is actually connected to this event and is actually subscribing to that publish event. And that way I can see that, and you can filter out your different event grid system topics to see which one it is. Now, I don't know if you've ever used this search functionality, but it is very tricky. You have to be in the right region in your filter. And so if you are looking in the East US and you created in Central US or East Europe or West Europe, you'd be in trouble. You wouldn't see it, and you'd be like, where's my topic? I don't know. It's gone. So here is a quick demo of all of that happening. So you can kind of watch. So we're going to get an access key, of course, in our storage account name. And this storage account isn't out there, so you can try these keys if you want, but they probably don't work. So I just wanted to call out not the connection string, just the key for this part. When you click on this, you can actually do functions or logic apps, but I would recommend doing functions manually, not through this interface. So this is the events within the storage, and then you just connect and say, I want my blob storage connection. And of course, once that's connected, it gives you this nice green check mark. Tells you it's connected. And then on this next part here, I signed in with my own personal ID, but I wanted to call out, you can do service principal or managed identity, which is probably a better solution, because if I leave the company, this no longer would work. That'd be bad, right? So you get the nice green check mark. Everything works. Literally, you've done nothing but click a few buttons, and it creates this logic app. It has a timer trigger that deletes blobs after 30 days. I deleted that, and then ultimately save the logic app, and then you can drop a file, and it will immediately respond to that event. There's a couple of other options here. If you have an integrated service environment, you can integrate that. You can actually disable it when you create it, which makes no sense to me, but you can do that. And then, yeah. So once it's created, it'll tell you you're going to lose your code, even though it's already created. That's another bug, but it is what it is. So you get your logic app here. Once you drop the file in storage, then, again, this is just reviewing to see that you can prove that you're connected to the event. So you basically have the hook in place. There's the hook. There's the event subscription. There's the circular going back and forth between them, so you can see how that kind of connects. There's the logic app, and ultimately, yeah. So we're going to go out here to the uploads. We're going to upload any file. It doesn't matter what it is. And once we do that in our logic app, we can review that it was triggered and succeeded, and then we have access to the blob URL through the data. So again, an event's just sending information, just the blob URL. Now whoever's subscribing to this needs to handle that. That's how simple it is to create a logic app to respond. Using functions a little trickier. You got to create an event trigger, and again, I would just recommend wiring that up by going into the portal or whatever tool you use, whether it's ISC or not, to create that subscription manually and select your function endpoint. All right, so the next thing then is Service Bus, and there's two different parts of Service Bus that we really care about, queues and topics. And the first one we're going to look at is queues. And here's the part where I want to call out for you differences between when I might use the Service Bus queue and start talking about storage queues, which we're going to end with. So if I'm making decisions as an architect of which type of queue I want to use, I always consider cost, which in my mind, storage queues are going to be a little less expensive. There's a lot less overhead cost to that. But Service Bus queues serve a couple of specific purposes. The number one purpose is this is the only place that you can guarantee an ordered queue. So I don't know why storage queue is actually called storage queue if I can't guarantee order. When I, as a computer scientist, think of queues, I think of FIFO. But yes, storage queues may be in order, but there's not an actual guarantee. And when we do it, if we get a chance, we'll do a demo maybe, but you can actually see it getting out of order. So the other thing to keep in mind is data size. So if my message size needs to be bigger than 256 kilobytes, I have to use Service Bus. Or better, actually bigger than 64 kilobytes, it has to be Service Bus. So I can go anywhere up to like 100 megabytes now with a premium, which is kind of crazy for the size of a message, but you can do it. You get dupe detection, dead lettering. Again, anytime you use a queue, you're going to get decoupling of your client and server sides. You can send messages, and then you can offload some of the work that way. The other two important things to keep in mind are the types of processing. So whether I want to be at most once or at least once, those are different ways to process. So with Service Bus Queue, this is the only way to also do at most once. So guaranteed. You can do at most once in storage queues if you write really good code and don't have any other competing clients. But in Service Bus, you can actually guarantee at most once by deleting it as you read it with the receive and delete option, or you can do a peak lock, which is the at least once, which means I'm just going to put a lock on it, but if I decide I don't get it processed, the lock expires and it can be processed again. So again, it's a Service Bus namespace, standard or better if you want to use topics, which I'm going to show in a minute. So you'll want to have at least a standard for that, and then ultimately local authentication, again, the SaaS token, the same thing we had for the thing. So you create a queue. In the queue, you can set different pieces of the puzzle, and there's this other really interesting and confusing piece of the queue. Are my queue messages in order by default? Yes, they are. If I have multiple processing that I need to do across messages, they're not guaranteed, unless I turn on sessions. So if I have a group of messages that need to be processed in order, and they need to wait for each other to be processed in order, so that we don't have like part 3 goes faster than part 2, so part 3 finished, so part 4 was triggered, but part 2 is still running, I have to use sessions. So you got to turn that on. It's a lot trickier to work with. So if you don't need it, if you don't want to turn it on, but once you need it, it can be a lifesaver. So this is what that looks like with the session. So here what you can see is 4 different data feeds coming in where you have processing that needs to happen in order for the specific things that we're keying on. And that session basically says, hey, this queue processes my session in order. And it also prevents part 1 from firing before, or part 2 from firing before part 1 completes. And so that keeps your processing and your transactions kind of synchronously in order. So again, we need the SaaS token for producer. We need the Entra ID if you want to do that. You got the data owner, receiver, and sender. Same 3 permissions, just an Entra ID instead of a SaaS token. And then ultimately, I wanted to call this out. If you do use Entra ID, don't choose these. The Service Bus queues are bad, the storage queue data contributor and processor, sender, and reader are bad for Service Bus. They won't do you any good. So it's important to keep that in mind. So when I create a queue, everything that you do with a SDK in Azure, pretty much for all these services, is going to be a hierarchy. So you need some sort of client, you need some sort of connection for that client, and then from there you need some more information. What queue am I connecting to? So that's essentially what we're doing here, creating a queue. And then what I wanted to call out here is the difference between at most once and at least once. So again, if I want to do receive and delete on my options, I can do that, and that allows me to say, once I get this out of the queue, it's gone forever. And then the at least one says, hey, I'm just going to put a lock on it. And the thing about that is you have to remember at the end to process it and basically mark it as processed. If you don't, you're in big trouble because then it goes back into the queue. So when we send it as a batch. So we're adding some Service Bus messages, and this is just some JSON for movies that's generated in the app. And then that sends it async. And then at the end of the send message, we dispose it, clean up ourselves, clean up. And this is the processor, again, handling it with a message handler. We start the processing async, and the processing then allows us to parse out that movie object and write it. And so with that in mind, real quick, throw out a demo. So this will be the Service Bus queue. And again, just to call this out, when we do our producer, we have that choice of which one we want to use for our client, whether we're going to use the options to do the peek and receive and delete, or the peek lock. So, yeah. So we're gonna that's on this receiver, of course. Let me send some messages to my queue. And we'll bring this over here so you can see it. Sent 17 movies to the queue, and then on this one, we're going to go ahead and receive them. maybe. There they are. So it's just processing them out. And this is doing the receive and peak lock, I believe, by default, set up with that code. And then at the end of that, we have to make sure that we process it out in the start processing, complete message. So that's one thing. If we don't do that when we're doing the send and delete, or peak lock, excuse me, then we end up with, goes back into the queue. So again, now all that code's out there for you, and you can see how that would work. But ultimately, that's the gist of working with queues. So the next one is topics. So queues are great because I got ordered guarantees. What happens if I have different clients that need to read different parts of the messages? That's what topics are for. So now what I can do is I can feed my queues once, and then I can put different filters on my messages to send to different queues. And what's really cool about this is every client has their own queue. And it's going to be every time. I apologize. Just got to get it in focus. So if I have different clients and I want to say, hey, only these messages go to client A, these messages go to client B, and these messages go to client C, this message goes to everybody, we can create different filters on our code to send the messages to the right place. So we filter at this subscription level, and we make sure that the subscription subscribes to their particular filter. So what that looks like, ultimately, when we do this, we create a SQL filter, a Boolean filter, or a correlation filter. And typically, you're going to do a Boolean filter that's set to true for sending all queues. So I send the message once, and it goes to all the queues. If I do a SQL filter, then I can filter it on different things. Like, does the subject contain client name? Does the subject contain this event? Whatever, or this message, whatever it might be, this piece of the puzzle, you can do it. So blob storage is always a really good example to filter and see this. There's millions of applications to this, but outside of blob storage. But if you think of blob storage, you have different containers. You could filter on the total blob storage account. You could filter on different containers. You can even filter on different types of images or messages. So you can do numeric values, whether a property has a value or greater than or equal to or less than. You can do some filter value is, filtered. You can do whether you have different strings you're looking for in the subject. So maybe you're looking for different pieces of information that would be in your subject you're sending. And a correlation ID, like something like critical or information to kind of route different messages to different places. So you create a topic this time instead of a queue. The topic has max topic sizes you can set there, time to live, things like that. So what we have in our code sample is we're going to create 3 subscriptions on the same queue. One for adult movies, and it's not the type of adult movies you're thinking of. It's just R or PG-13. And then we have family movies, which is like PG and G, and then we have all the movies, which is all of them. So those 3 subscriptions then can be filtered. As we send one message, it will go to the right queues, and you can view all of that in your portal while it's happening. You can see the different queues and the messages being processed. Again, the access token is done to allow different pieces to read from the puzzle. So we have to have, in this one, there's a manager project which creates the 3 subscriptions and sets the filters. So that's this first part here where you get the root managed access connection string. So remember I said God mode is only for unique scenarios? This is one of them. So if I want to have access to the top level of all of my topics in that namespace, then I need to make sure that I have God mode, so that I can create a new topic in the namespace. And then it creates the 3 subscriptions. Once we have that, we have the ability to filter those movies across those subscriptions and receive them and send them to the 2 subscriptions. So the client says, make sure the topic's there, make sure the subscriptions are there, and then ultimately creates them if they're not. And that is about all it does. And then the producer is going to send the movie, and the movie's only sent once, and it will go into the appropriate queue, and then the sender will be able to, the receivers will be able to see it. So you get subscriptions going to all 3, and then a message count of being able to determine, how many messages are in each queue. Even though I send the message once, again, you can see how it goes only to the appropriate place. Oh, you might say, well, there's 17 messages, you only have 16 filtered. What happened? One movie was in the 1950s and it doesn't have a rating, so it didn't go anywhere. It got lost. So then this is just calling out the code, but ultimately we have to choose one of the subscriptions when we process it, and that process will then filter by that subscription and make it happen. So this is just the receiving part, and then ultimately that allows me to make a choice of which subscription I want and prints them out, and then you can see that all happens. We have enough time, and I know you're probably getting hungry, so I'll go as fast as I can, but I want to show you this because this is probably my favorite part of the whole thing, is this topics. So again, this is the Service Bus Pub Sub project, also available in the repo. And all of my connection strings are preset. This is my administrator project. Again, this is the one that's creating the different subscriptions. I don't think I called this out good enough in the code, so I want to show you where I created the actual rule filters. So there's one. This one is for the all adult movies. So you can see that on the subscription, when I created it, I said listen for this SQL rule filter where the MPA rating is equal to PG-13 or R. So it's very similar to SQL. It's a SQL rule filter, and it allows me to do that. The other one is the same. It's an MPA rating of G or PG, and then the true filter is literally just passing it true. So that's PG or G. The true filter must be up here. Yeah, so all movies just sends a new true rule filter. There's nothing special about that at all, so send them all there. So this will run, and it will create all my subscriptions in my portal. So let me actually show you that, because this is pretty cool too. So inside of my service bus, if I go to my topics, you can see that it will create movies to review if it's not there, and ultimately what it did was it said they're already there because I ran it earlier, so we wouldn't have to wait for it. But you can then see your subscriptions, and you can see your message counts and things like that right here in the portal. And then you can even peek at them if you wanted to see what got filtered to make sure it works. So once I have it, let's produce some. So we're going to do the publisher. And again, this is just the same code that we've been seeing over and over again. We got our SAS token that we connect as a producer, and it says, hey, I'm going to publish the movies. So all 17 movies have been sent into the topic queue. And essentially what happens then is all three of the queues get their own, or all three of the subscriptions get their own queue. So let's make sure that we have some stuff here. There we go. So again, the filters allowed all the movies to go into the all movies subscription, and the adult movies with PG-13 or R went into that subscription, and the all family movies went to the other one. All my client has to do then is connect to the correct subscription, and they only see the messages that are meant for them, and they're all still in order, and they're all still independent of the original thing. So if I delete from the all family movies, it doesn't delete from the all adult movies. It doesn't affect the all movies. They're all independent queues, which is what we get to see in this final part when we run the consumer. So we can choose. So let's go ahead and just do the family movies. And we can see that we're going to receive the messages just from that subscription. All 4 of them, and that's it. It processed them. It's done. So we got, I don't know, Top Gun and Pulp Fiction. I don't know if Pulp Fiction's a family movie, but maybe you guys think it is. I don't know. So again, you can run it again over and over again to see how this processes differently. But the really cool part of that is, again, watching this side of the equation and seeing how only the all family movies was cleared out and the rest of them were left alone. So that client got all their messages, the other ones haven't processed yet. That's awesome. So, we could run this all day over and over again to see that, but at the end of the day, it would just end up deleting them all from that queue. So, if I print them all out, it'll receive all the messages, and it's now processing them out of the queue. So that's probably good enough on that. And then that just leaves storage queues. But before I do that, does anybody have any further questions about that topic before we move on? Okay, let's go to lunch, right? So, all right, let's do the storage queues then quick. And so storage queues, again, are probably the cheaper option. And they are queues, except they can't guarantee order. And there's two things about this. Again, I train a lot for AZ204, so I'm sorry if these things are a little bit dry. But if you're making an architectural decision, they're pretty important. So I like to call it out. The message size has to be less than 64 kilobytes. If it's going to be bigger than that, it's not going to be able to be stored in the storage queue. And then you also have to use storage queue when it's greater than 80 gigabytes of total data. So you think of storage, you think, wow, that's lots of storage. Awesome. But the message sizes are smaller than service bus. It's not necessarily intuitive. So just keep that in mind. But if I'm going to have over 80 gigabytes of data, service bus can't handle it. You'd have to have multiple service buses and all kinds of orchestration around which ones you're in if you want to go over 80 gigabytes. So if you have a terabyte of data or something ridiculous, storage queue is your option, right? The tricky thing about storage queue is how you actually handle the data a little bit differently. So again, same hierarchy. Connect to the storage count, create this queue client. You can create the queue. You can send messages to it just like you would expect. Again, we're converting movies to JSON and sending it in there. You get this array of receipts then that you're getting back. And if you want to leverage those messages, you need that receipt ID to be able to directly process them if you want to do updates on them or something. Now, that's the really interesting case, though, because if I take that receipt and I update the message in the queue, it actually goes to the bottom of the order. Now, maybe that's correct processing because I did change the message. But if that was supposed to be handled before the other stuff, we're in big trouble. So you can peek at them. There is no at most once in storage queue because you can't delete until you're done processing. You can't just receive and delete at the same time. So you can't guarantee at most once. If you only have one consumer and you're peeking and deleting every time, you can guarantee at most once unless it fails. If it fails, then of course, that's a whole other world. But so you update the message here. This is how you can update. And again, once you update that, this one updated from Top Gun to Top Gun Maverick. And when I did that, it went to the bottom of the queue. And then ultimately, they're out of order. If you were thinking Top Gun was the top movie, all of a sudden it's the bottom movie. So you can also set the number of messages you want to receive on a batch. So you can say the maximum messages I'm going to pull is 20. And then you have to make multiple calls if you have more than that. And you're just deserializing the data. So that's just basic code. This is the most important part. So we saw similar when we completed the process in the service bus, when we did the peak lock. And in storage queue, you have to delete at the end. If you don't delete the message, it will go back into the queue. And the way queues work in storage queue is it basically puts a timestamp on when you leased it, right? And so if it's a long-running process, you actually have to send a notification that I would like to extend my lease. And if you do that, nobody else can get it out of the queue. What it also does is it makes it really hard for any other client to see that until after that time expires has done. So if you lock your messages for an hour, then you lose your thread. You won't see that message again for another hour. And it's just kind of hidden. You could probably see it that it's there in the portal, but I don't know that you could even read it. This is, again, updating with the timestamp here to do that leasing. So if I want to extend the lease, and then deleting from the queue. So that's the last demo officially, and that one is just the storage queue. And same thing with the code here is ultimately all out there for you if you want to run these on your own later, or if you need to see these again at a slower pace. This one is utilizing storage queue. And again, we've already kind of gone over the code, so I don't know what I just did there. Ultimately, this just gives you options of how you want to handle data with your queue. It creates the queue if it doesn't exist. It then says, hey, let's get all the receipts so that we can update Top Gun using that receipt. And then that's where this is doing that. Ultimately, receiving the messages. And then it asks you if you'd like to extend the lease. And if you do that, again, they get locked for an hour based on whatever your time span is here. Really, this is a time span of an hour. You could set that differently, but once I do that, they're basically locked, and it won't let me process them again until that hour is exposed or done. And that's the last part's just clean up the queue if you want. So you can run this idempotently because it will create if it doesn't exist, or it'll just use the one that's there. So no worries there, but use the right project would help. And I guess I could probably just F5 this one. There's only one project. So it's adding messages to the storage queue. And basically all those movies were added. And then it asks, do you want to process them? So I'm going to process them. And then it says, would you like to lease the message for 1 hour? I give a note, don't do this because you won't be able to delete them for an hour. So we're going to say no. So there's the processing of the messages out of the queue. Again, everything kind of looks in order, except for Top Gun, because Top Gun got moved to the end when I updated it. And would you like to delete the queue? If I say no, it will, leave it there. And that's essentially the demo. I'm going to lease them really quick just to show you the pain of that. So again, if I don't delete the queue, this is idempotent, so it wouldn't matter. This time I'm going to say, I'm going to process, and then I'm going to actually lease them. So I'm going to say yes. So now it's going to renew the lease on all of those messages. Now after that, it's going to error out, because it's going to say, I can't read these messages that you just locked up. So big problems. And then ultimately, if you go into this portal, this is why I'm interested to see in the storage account, wrong storage account apparently. Okay. All right, so I was hoping to find the storage account that those were in. I thought it was in that one. Shouldn't be here, but I'll check this one anyway. Nope, okay. I'm not going to be able to find it. In the interest of your personal sanity, I'm not going to make you watch me do that. So, you've seen all the different message processing that's happening along the way. You've seen different types. Hopefully, if you had questions about which one you should use when, you now kind of feel like, oh, I'm pretty confident about that. I know when I should use this. Have enough information to be dangerous about how to use the code if you want to. And then if you're still using like in-service bus or RabbitMQ or something to wrap all this, now you have a little more information about how the underlying stuff might work too. So does anybody have further questions about all of that? Is everybody hungry? Yeah? All right. Well, let's go ahead and wrap it up then, and have a great lunch. Thank you again for all of you for coming. I really appreciate you giving me your time.